Alright, here's a little circuit that I made. I'm having to remake the video because I used the damn wrong recorder again. It's based on, this is back of Marky Hazen's Exploring Electronics Devices book. This is a copy of the 723 LM723 voltage regulator, so data sheet. So, but you can see that this is actually meant for a 50 volt supply, and they have a negative version down here for a negative 100 volt output regulator, but don't do this one because it doesn't have current limiting. That's the great thing about the 723 regulator that you don't get out of 3-terminal regulators, is that you can have adjustable current limiting in it. It's got that functionality built into the chip, and that's why it's remained a popular chip out there, because it's actually rather straightforward to implement in a lot of cases. And I built a lot of circuits based around this regulator, including some of those power supplies. Over there, like in that big box, at least one of those is based on 723, and it's adjustable down to 1 milliamp up to 2 or 3 amps. And that one you see right in the, right to the right over there, is this one right here. If you're looking at my mouse cursor, is based on a 723. It's a battery charger, and that can go up to like 2 or 3 amps, and down to like 10 milliamps or something. That only goes up to like 20 some volts though, but that other one goes up to about I don't know, 30 volts or something like that. But at any rate, yeah, this is a versatile little circuit, and I made a lot of changes to what you see here. And here's the circuit board to it. But yeah, this I'm just going to refer you to the other video I made, because it's like hot in here and I don't feel like going through the whole thing. So I'm going to go ahead and put both videos, including the one I did by accident, because it does explain some of the things on there. Hold on. And I'm going to take a crack at it anyway. If I get sick of using the wrong recorder, I'll use this one. Because a lot of times I use this one, and then I meant to use this other one, but the other one, the little box to it floats on the side of the screen. You can't see it because it disappears when I hit record. But at any rate, I'm going to move this over here, and I'm going to switch this to picture mode so I don't accidentally do that again. And I'm going to hide it over here from now on. Well, shit, I can't minimize it. Well, I can minimize it right there. Let's see. So hold on. Okay. I went ahead and actually drew a schematic of the actual circuit you're seeing tested here. So, you can see a lot of the, this is what I recommended if you wanted to make a variable current version, that can go maybe from 10 milliamps to 150, because the exact current limit is hard to predict because it's based on a diode voltage drop. So, so you're going to have to do some experimentation if you build a circuit like this. And again, this is a TIP41 that I actually used, as opposed to, what I used over here in the, the original schematic. But again, I had to make several modifications of it, because I did this 2 years ago, so I can't explain some of the choices I made here. At least not superficially. I just wanted to see if the damn thing worked, honestly, because I was just curious about a high voltage regulator like this. But like I said, I don't know exactly what transistor I use. This is out of my junk box, and it's like a TIP, a TIP 41S. So I have no idea what that is. I mean, I can't tell you what the SOA is on it. So I've just got to assume it's the A version, and it's like limited to 60 volts. because I make a B, which is 80 volts, and a C, which is 120. But since I got this out of a Jamico value pack, containing like 100 different transistors, like 25 years ago, I assume it's the lowest voltage one. So I don't want to run this much above the, the 65 volts I'm running this at, because I'm using the, 2-time, dual power supply to generate 65 volts. And that's the limit I've got it set at. But I got this little cheesy potentiometer on here, which allows me to adjust the current on it, or the voltage on it. So, I can go down to a maximum of about 35 volts. This thing's pretty finicky. But it doesn't have much actual adjustment range. That's why you're going to want to tweak this value here, because this is what, this is that potentiometer I just altered right there. But like I said, if you want a more larger range, you're going to have to look at, changing this whole voltage divider ratio, because this whole thing was experimental. I really didn't know what was going to happen for sure. Again, you can only get so much just out of the data books, but I modified this too, from my 390 ohm value for R7 that you see in the schematic over there, and I made it 2 watts because this is going to dissipate a lot of voltage. As you start lowering the voltage, on this thing, well, that is basically making this whole regulator float down almost like an elevator, limited by this 36 volts worth of Zener diodes here. So if you had like 100 volts down here, at ground up to your power supply, the drop out of this thing again looks to be roughly like 10 volts, where I have it. So you can generate anything, with the current situation I have, up to 50 volts, and theoretically down to about 2 volts or so. But you got to understand something about these old 723 data sheets is that they really don't have, all these are fixed voltage designs. So there's no variable voltage designs in this, and I've actually made a number, of different 723 projects, and in every one of them I wanted to be voltage variable. So I've had to make my own designs basically off of everything. Because even in Hazen, in his book, when he talks about 723s in here and stuff, he really doesn't, elaborate much on making more complex designs with this thing. So, but it's a very versatile little chip, and they're still easy, plentiful out there because they're so popular. And that's why they're so popular, because unlike almost no 3-terminal regulators allow you to actually adjust the current. And that's what we're doing here. This little set of resistors here is actually what's responsible for setting the current. And if you see, my notes over here in the original schematic, it says it should be about 150 milliamps maximum current, with 4.3 ohms in there. But, but I wanted to put more. I mean, in theory, this should only be limited about, 30 or something milliamps with this in it, maybe 50, but it seemed to be a little higher now. I'm going to test it again in a second. But anyway, the other thing you've got to really watch out for on a design like this, and this isn't, again, this is for fixed regulators. It's meant to be part of a piece of equipment, not as a standalone power supply. So that's not what the intent of any of these are in any of these example circuits, and there are quite a number of them in here, as you can see. But none of them are meant to be variable or used as a lab supply or anything like that. But one of the drawbacks to this thing, you can see from this circuit, is you've got to have a minimal load on this thing, because if you don't, what's going to happen is, let's say you disconnect your load or something goes wrong with it, but basically it becomes removed from the circuit. Well, then this chip is going to try to get its power, instead of through this chain of events, this chain of circuitry here, it's going to try to get its power, through this resistor, going through its VCC, and out one of these terminals. These are basically op-amp, input reference terminals, and there's a VREF, so it's you're right here. You're trying to get your power for the chip out of the output of an op amp, and here out of the inputs of an op amp, a different op amp. So it's going to try to get its power through this chain down to ground, and that'll probably destroy the chip. So if you have a minimal load on it, you kind of help ensure that shouldn't happen. So so it's really advisable to do that. It's one of the additions that wasn't in my schematic because I didn't realize that back then. But yeah, I would have fried this thing sure as shit if I would have hooked it up with no load on it. But you can kind of see that, like I said, if you put a 50 ohm potentiometer in addition to that 4.3 ohm, that'll set the absolute limit. This should give you a current range of, adjustment from 10 milliamps up to 150 milliamps. And again, you could scale this voltage up if you use the right transistor to, well over 100 volts. I think they said 150 volts or more could be done in this data sheet somewhere, in the fine print or somewhere. But the exact values required to get the exact current limit, you're going to have to experiment with, because again, it's a little, it requires some experimentation. So, this seems to be working okay. I know I'm drawing less than 20 milliamps, 25 milliamps anyway. So, at full voltage with that load resistor. See, that's my current setting resistors right there, and the load resistors, are these 2 half-watt these 2 half-watt resistors that I got there that are like 1.5K each, so for a total of 3K. So, and here's that 390 ohm resistor that I changed to 470 ohm, just to lower it. It didn't need to have that much current, and that makes it a little easier on the Zener diodes here, and and the resistor itself doesn't have to be that bad. I think it's going to work out to 1.2 watts with a full load across it. But anyway, it's just an interesting little circuit, and let me run some tests here and pull some other things up, and I'll get back to you. Oh, and by the way, I wanted to point out that, the transistor, even without a heat sink on it right now with this dummy load on it, is running cool to the touch. I mean, it's warm, but I'm not going to run any prolonged tests on it at high voltage. I just wanted to verify that the circuit works. So anyway, hold on. Okay, so this shows what the difference is. Again, it should have been about 50 milliamps maximum, as an eye limit on this thing, but I need to get an auto focus camera. But like I said, it's 53 volts and 20 milliamps. Now, I've got a 100 ohm, high power potentiometer set at 100 ohms that I'm going to put across that thing. Just briefly, again, I got no heat sink on the transistor. It should be able to probably handle that. But at any rate, it's a 100 ohm load, so let's see what it does. Notice the current reading on that, the voltage. 111 drops down to 10 volts. So that's the current limiting in effect. Because again, at 53 volts, you put that, it's trying to draw like half an amp with a 100 ohm resistor in it. So it did pretty good, for going from 54 volts down to 10 volts, but still maintaining a voltage. And transistor's just a tad warmer for that brief time, so it seems to work okay. But again, it's not what I calculated, and again, that's why I say you're gonna have to fidget around with the values yourself, because again, that's a 9 ohm plus a 4.3 ohm resistor, so it's 14 ohms or so. So but now that you know that value, again, your chip may be different though, because again, it's roughly a 1 diode drop, about a 0.65 volt difference between, your, this line and your C-sense. So that's your I limit and C-sense line. So it's never going to be more than about 0.7 volts max. But again, what it actually is depends on your chip and everything, so you'll have to do some experimentation. But the point is that you can make adjustments until you get the comfortable range you're looking for out of it. And two, again, you saw the limited amount of voltage adjustment range I have on this. You see, I'm dropping most of the voltage across this. I'm trying to keep the current really low. And again, don't ask me specifics. This is like 2.5 years ago I designed this. I don't remember a lot of the choices I made here and why. But but I know we're trying to drop this big voltage across this thing so I can make it adjustable. Like I said, the one they did is not adjustable, but it still has, a reference there for this R2, which you select out of a table or an equation they have. But it's still got, some kind of limit too, but it still would have the same problem if you attach this thing with no load. It would try to be powering the chip, through, like this, NI line here, down to ground. I'm not really sure. I don't remember what the NI line is. But at any rate, because it's not on my schematic, but I'm sure I'm probably using it. It's just called something else. I don't know. I'd have to look into it. But, because I don't even know what pin that is. I'd have to look up now. Let's see what it is. There should be a pin out here somewhere. Let's see. NI. Where's NI at? Non-inverting input, I guess, is what it probably means. Pin 4. Yeah, but I have no idea. I have no idea how that reference is. But anyway, mine works. So, works good enough. But anyway, let's see. But at any rate, like I said, the 723 is a versatile chip. I've used it on a number of different projects, including this one I'm about to test, which is a switching regulator. I guess it's supposed to be a booster. I don't know, but I'm going to find out. Again, got that sort of out of this data book loosely too, but I had to modify it, make some modifications of it. So I'll see how that goes later. But here's an example of one of the power supplies from that box over there. That I did. In fact, because there's like 3 power supplies in it. And you can kind of see this is a 723 regulator, and I did some elaborate things with it based on the transformers I had on hand and everything else. Here's a stock meter I bought from Amazon that conked out on me. That's like a 5-digit precision meter or something, but yeah, that thing does. Meters generally suck. I mean, you have to, I'm not even going to go into it. Every single one of those you got to basically boot up on their own. In fact, I have to, really do some tricks on, the 2 ones you see lit up. I actually have to have a separate power connection so I can pull it and then, restart it after I've started the power supply. And the other one is just to this power supply right here, that we're looking at, it's just gone flat and dead. So, I mean, I got to, open it up, and it's probably developed the same damn problem. Anyway, those things suck. They're supposed to be, when they work, they're great, because they're multi-digit and everything else. But man, that's bullshit. They won't boot up. So I'm gonna have to figure out, I don't know, one of these days, some circuit if it's worthwhile to actually do that for me. But that was a quick and dirty fix. Because here's that power supply that you're seeing lit up over there, but it's a different design. You can see it's based on some op amps and regular regulators, and this shows you the kind of effort you got to take to actually make like a typical 317 kind of regulator variable current. So, because that's what this is, you can vary the current, and it's actually a dual tracking design, and it actually tracks pretty well, surprisingly. That this is a dual tracking power supply that I built, and it can go up to like 1.5 amps or something like that. I don't know, I really was always too scared to test it to its limits, given how big of a pain in the ass to make it was. These are all the fixed regulators, voltage supplies I have built into it too, just for shits and giggles. I had a shitload of regulators, might as well use them, right? This was a fan controller thing, I think, that I never built. I don't think I built that either. Or if I did, I don't know, didn't use it for some reason, or never tested it, I can't remember. But this regulator is, again, variable current, you know, and variable voltage, so it can go from like, what, I don't know, 2 volts to 37 or 25 volts, 35 volts or something like that. Maybe it was 32. I know it's over 32. It should be 37 was what I was targeting, if I recall. But at any rate, you know, you can do some really good stuff with these 723s. See, I built and tested this. I didn't make a video about it because it's uneventful, but you know, this is you can adjust it from 0 to 3 amps and from 3 to 30 volts. I don't know where I got this design from, but I don't think it's mine. I might have gotten it off the internet or something. I don't think it's in Hazen because he doesn't get this elaborate with the 723 regulator anyway. So it works. So current limiting and everything. But again, I just got those stupid little blue potentiometers on it, you know, to vary the. Let me see if I can find that real quick. Yeah, I think this is it right here. See, it's got those. Well, shit, man, I need a fucking camera that autofocuses. I mean, it's great because you can zoom in really close with this camera. You know, like my phone camera will autofocus, but not this close. So, anyways, the only one I'm lucky to have it that does that, but I keep having to fuck with it all the time. But yeah, it's based off these, you know, little multi-term pots and that I got off Amazon or whatnot, and you know, and it works. But yeah, you can adjust the current and the voltage, and it's got a coarse and a fine current adjustment, and that's the voltage adjustment right there, I think. So, but I mean, it works, and you know, there's just a lot of versatility in this design, and you know, but like I said, you know, looking at that more elaborate design, just trying to work with you know, just trying to get a 317 where you got variable current, even if it's just not a dual tracking supply, is really quite tricky. So, you know, there's actually a lot to it, and there's different ways of going about it, but none of them really allow for it. The only circuit I ever found with the 317, you know, that really worked was actually right out of the data book. And it's, you know, kind of hard for you to see here without changing the fucking focus again. But, you know, that black, I'm about to the limit of the cord on this camera, but that black supply right there, it's a portable supply I built. That's based on a circuit that's right out of the data book, and that's actually the best damn operating power supply I've ever built. It's based on an op amp, and I mean, I wish I had it handy here. Now hold on, I'll see if I can find it for you. Yeah, this is basically the schematic, and I actually, you know, this isn't the data sheet version, but this is out of an old electronics magazine I have, that, you know, this is supposed to be like a dual 50 volt power supply, but it's based on a high powered, you know, version, you know, of a 317. So, and it's got some boost transistors there, which are pretty high voltage. It's supposed to be a dual 50 volt supply, you know, with variable current stuff. So I based it partly on this, you know, because the one out of the, you know, and partly the one out of the data book. And you can see this in any data book on a 317 practically. You know, this basic circuit is in almost any data book on a 317. And, you know, here's a more expanded view of the whole thing and what they were doing with it. So, you know, let's see, RE Experimenter's Handbook or whatever it is, but it's actually a magazine from way back when. But anyway, it had some test equipment projects in it. Those are the circuit boards I pretty much made, but I did not build that one. And I was, here it is. Here's the data sheet version of it. So you can see here, this version of it really won't operate down to 0 volts. So, that more elaborate version of it you saw would. So, but it's a 317 regulator, and, this is still limited to, it's like for 5 amps and so forth, but, it's still limited to the voltage range, roughly the 317, like 37 to 40 volts, or, less than 40 volts, I know that. But then they use an op amp as an adjustment, and this thing works like crazy, and it's got an LED current limit, so when it's in current limiting mode, it's the only power supply I got that tells you, or that I ever built, that tells you it's in CC mode, but it'll operate in CC mode quite reliably. And, but this is the schematic, of the power supply that you see over there, and it's got to have a negative supply in order for you to run this thing down to 0 volts, because it's still a 317 based regulator at the end of the day, and those only generally go down to 1.2 volts minimum. But I also built some, just some regular regulators. Again, I had a shitload of them, so I put some additional little utility supplies in it for general purpose use. But still, this is the exact circuit, I pretty much built over there. And I don't think I modified it much, if at all. Again, it was like over 2 years ago that I built this thing, probably 2.5. But it works. I mean, it works. It's the best power supply I've ever built in terms of what it does and how reliable it feels. Again, there may be some things that I haven't found out about because I haven't used it a bunch, because it's meant to be a portable supply. I wanted something I could easily carry with me somewhere, because I often needed to have a regulated supply. It was a pain in the ass carrying one of my lab supplies, so I wanted to build a more portable one. So, and I can't remember what the specs on it are, but but this is basically basically it. So I mean, I got some current adjustment knobs on it, coarse and fine voltage settings, and there's a constant current LED on it. There's some of those utility supplies I talked about, and this will put out some current. I forgot what the specs are. Maybe I can read my own notes. I don't know if I've got any, but yeah, I mean, like I said, it's a decent little power supply. Guess I can plug it in for you. Let's see, where's the shit. Okay, there it goes. See, I even built a fan into it and everything. Although I don't know if you can turn it off. It's a little annoying. I hate things with fans in it on all the time. But yeah, see, it's got a regular, voltage output, and like I said, I got, a milliamp resolution meter in it. And this one actually works, unlike those others. But yeah, so you can, adjust it down to, pretty low voltages. In fact, let's see. It's been a while since I've used this thing. Oops. At least it goes down to half a volt anyway, which is good. It may or may not need to be down to 0. It probably needed some additional fine tuning, but hell, that's better than 1.25 volts. And up to about 30 volts, and then you got current range adjustment and everything else. But it was a nice little supply, so I really recommend, if you want a really little lab supply that can do more than a couple of amps. I mean, yeah, it's basically a 2N 50. Yeah, this is a PNP transistor, so I actually pulled this off some equipment, but You know, it's a 2N5053. So, but just any suitable SOA. You know, most power transistors like this are going to be safe up to, you know, 30-volt drop across them or more. Just not much more usually. So it's, if you want to pull some current out of it, like, you know, a couple of amps or so, I guarantee you this can do at least 2 amps. But at any rate, it's just, you know, but it's still rather complicated. You know, that is a complicated circuit. You know, that's a complicated circuit, though, that try to get this kind of performance out of a 317. But again, if you want a lab supply, this is a good little lab supply to build. You know, but I'm just still saying the 723 is a very versatile chip too, and it's no more elaborate than this, and you can do a lot of things with it. You know, try to get a 317, you know, regulator to, you know, as a 100-volt regulated power supply, you're going to have some difficulty with that. But at any rate, you know, it's you know, it's a versatile little chip, and I've done a lot more with it, like that battery charger and a bunch of other power supplies I've built. But anyway, yeah, I just wanted to, you know, fill you in on that, and, you know, in the hopes you might find some of it useful. So, cheers.